So if we further elaborate, now we were taking the case of only a ball hitting the ground, but suppose you have two masses like m1 and m2, and their initial velocity is u1 and u2 before they hit each other, and after the collision the velocities become v1 and v2. Now for that case, what will be the formula for coefficient of restitution? So here, as you can see, that here you had v, and the velocity of ground, that is your second body, was 0. So v minus 0 and u minus 0. So means it is the difference of the velocities actually. Okay. So here you will write then, when you will have two velocities, so v1 minus v2. Okay. So student, this is the way to remember now. Okay. So this was v minus 0. Okay. And this was u minus 0. Is this clear? And now instead of 0, I am writing here, because now it will be v is the first body, so it is the v1 minus second body, and here also u1 minus u2. So it's so simple when there are two bodies, and that is coefficient of restitution. Now we also say this v1 minus v2 as relative velocity. So after the collision, after the separation, so after the collision or separation, so this is the relative velocity of separation, obviously after collision, and this is the relative velocity of approach when they were approaching each other before the collision. So that is my coefficient of restitution. Okay. So now this concept is complete. Now let us do some simple questions from your NCERT based on this concept. And so open your NCERT, page number 135. So on page 35, question number 6.6. Let us do this question. 6.6. A part. Underline the correct alternative. When a conservative force does work on a body, the potential energy of the body increases, decreases, or remains the same. What is the answer, students? Yes. What is the answer?
Decreases.
Decreases.
Okay. So when a conservative force does the work, let us see this example. This is our Earth, and Earth is this ball is at height h, and when you leave this ball free, it will be attracted towards the Earth. It will come down. So you can see that here the potential energy was mgh, and at the ground its potential energy is 0. So always remember this thing. See, this NCERT book is, means it's a treasure that you people have. Okay. So do these questions once, twice. These are very important basics. So conservative force when doing a positive work means what? Means the so force work done is equals to F dot S. So it means the angle between them is 0. Okay, positive work. Okay, so force is downward, and here displacement is also downward. So both were downward. So work done was positive. And if you are supposed throwing the ball upwards, okay, so here the gravitational force is working downward, but the displacement is upward. You have thrown the ball up. So in this case, potential energy increases. Okay? And work done. What is the work done by the gravitational force? That is F dot S. So work done by gravitational force is gravitational force dot S, and the direction of the gravitational force, you can see that it is downward, whereas the displacement is upward. So angle between them is 180 degrees. So cos 180 degree. So here we will have negative work. Okay. So when you are so here the work done by the gravitational force is negative, and that will comes out to minus mgh, whereas work done by the external force will be positive, and that is equals to plus mgh. Okay, now B part. Work done by body against friction always results in a loss of kinetic energy or potential energy. So this is the ground, and here I have a box, and this boy is pushing this box. Okay. So, and there is a friction. There is a rough surface. So work done by the body against the frictional force. So I'm doing the work against friction, right? I'm pushing it this way, and the frictional force is pushing it this way. So both are. Now what will be the result? And suppose after pushing it, this is moving with 10 meter per second. So what will happen if I leave this block? So will its speed increase or decrease?
Decrease.
Decrease. So speed decrease, and it will comes to 0. So what will be what this body is losing? Kinetic energy or potential energy?
Kinetic.
Kinetic energy.
Kinetic energy.
Yes. So it is losing the kinetic energy. So kinetic energy decreases. Okay. So kinetic energy loss. Next part. The rate of change of total momentum of a many particle system is proportional to the external force or sum of internal force of the system. The rate of change of momentum. So what is F? Newton's second law. F is equals to dp by dt, and that is equals to F is equals to d by dt mv. So m is constant, will come outside, and dv by dt is equals to acceleration. So that is ma. So question is the rate of change of total momentum of many particle systems. So this ball also has many particles, isn't it? Is proportional to the external force. Is it right or not?
Right.
So this change in momentum, does it depends on external force or internal force?
External.
Whenever students you are writing only force, it always means external force. It always means external. Whenever you are writing 2, it always means plus 2. So similarly, whenever you are writing force, it's external force. Why? Because internal forces always cancel out each other. So suppose there are two particles inside the body. So according to Newton's third law, both the forces are equal and opposite. So they always cancel out. So that is why the particles, the internal forces. So that is why the sum of internal forces is always 0. So this thing we will do in next chapter also. Fine. That the sum of internal forces, and you have understood why the sum of internal forces is equals to 0 due to Newton's third law. So this F is always external. So obviously that is Newton's second law, that F external is directly proportional to dP by dt, and this is F external is equals to m into a, which results in this. Okay, next part, D part. In an inelastic collision of the two bodies, so inelastic means the kinetic energy is lost, the quantities which do not change after the collision are the total kinetic energy or total linear momentum or total energy of the system of the two bodies. Yes. What
Total
is
energy of the system.
inelastic collision? Yes. Inelastic collision. Yes, students. Rest of you can also tell what is conserved. Inelastic word itself means that initial kinetic energy is not equal to final kinetic energy. This is the meaning of inelastic. What is the meaning of collision? Collision means momentum is conserved. Okay. And we are assuming that the system is isolated. So what is
Total linear
conserved here?
momentum.
Yes, conserved total linear momentum.
Momentum.
Obviously, kinetic energy is not conserved. So what is the third option we have? Total energy of the system of two bodies. Is it conserved or not? I told
Yes,
you these
sir.
are the two universal laws, right? So which are always conserved. Total energy of system. Whenever you have an isolated system, closed means particle cannot enter and exit. Isolated means sum of external forces is 0. So these are the two universal laws, students, everywhere. Don't forget to apply these two laws. Okay, total momentum is conserved and total energy is conserved. Okay, now note it down and send me a